In this video, we're going to look at some business examples of predictive classification to understand the basic idea behind it. So first, the idea of predictive classification. So first, we're talking about prediction. Prediction means that we are looking at past data that we've collected in order to predict what we expect to happen in the future. Then this class of problems we're looking at involve classification. And that means that what we're trying to predict is a limited number of classes or categories, usually two or three possible outcomes, perhaps more, usually not that much more. But in particular, we are not trying to predict numeric values. So, for instance, we're not trying to predict how much a customer might spend in our store, which would be a specific number, but we are trying to predict specific categories, which would be perhaps would a customer buy or not buy? So that's a yes or no. Or would they buy a product type one, two, or three? So those are three possibilities, not how much they would buy, but what they would buy. One way we can look at it is with a sports analogy. If you look at this basketball that someone just shot, and right now it's in suspension. Question is it a goal or is it not a goal? And if the basket falls in, if the ball falls into the basket, then it's a goal. But if it falls out, then it's not a goal. And critically, it doesn't really matter if it came close. Close doesn't matter. It's yes or no. Is it in or is it out? And that's the essence of classification type. In terms of machine learning, classification is a supervised learning approach. And supervised learning means that you're giving the computer past values of what is true or false. So, what were the true values of the classification from the past? And based on that, the computer is going to learn the pattern of what determines true or false. And then when you give it new data without the outcomes, then based on what it has learned, it can try to figure out what will happen in the future. And that is supervised learning. So now we'll proceed to some specific business scenarios and examples. First, here's a marketing example. And this is a scenario of a subscription company. So a commercial company that has subscription customers. And the question is, will customers maintain their subscription to our service? That's will they stay loyal, or will they end their subscription? Will they churn? So we all face this. So if you have a mobile phone, you're subscribed to a company. If you have internet access, you're subscribed to a company. And thinking of it from the company's perspective, the the advantage of subscription models is that you have your customer base and you don't have to look for new customers every month. Once you've subscribed a customer, they stay, and customers stay for many months, even sometimes many years, with so little effort. You just need to keep your product and service going, and they just stay. However, occasionally, some of your existing customers might leave. We're not looking at trying to gain new customers, that's a different scenario, but we're looking at your existing customers. Some eventually end their subscriptions. And this is something that you normally want to avoid because the cost of getting a new customer is much more, probably at least 10 times as much as the cost of keeping a customer you already have. And so companies really go out of their way to avoid losing customers. And the question here is not trying to predict how many customers you have or in the next month or so. The the business goal here is trying to predict for a specific customer, what are the chances that that customer next month will remain our customer versus if they will churn, that is, they will stop being our customer. And the advantage of this is that you can strategize how much effort and energy and cost to spend on retaining your customers. I had experience of this when I first subscribed to fiber internet when it first came to my building. There was only one company, Orange, that brought it, and they had a pricing of around 45 euros per month, but they gave a discount where we paid only 22 euros per month for the first 12 months. And so I took that right away. But at the end of my 12 months, before the end of 12 months, I received an offer from Orange that instead of switching to the regular 45 euro package, would I like to go to their low end fiber option with Sosh for just 30 euros a month. And I took it right away. Now, what is interesting is probably what went behind this was predictive analytics because they analyzed my internet usage for the 12 months where I first used it. And there's not only internet with Orange, there's other services like television subscriptions, there's phone service, but they realized that I, as a customer, didn't use any of those things. I just use the internet and nothing else. All their other premium offerings for which they justify 4 or 5 euros a month, I didn't use it at all. And I looked like a prime candidate that at the end of my subscription, when my price would nearly double, I would probably switch. And actually, I was looking to switch. I was looking around who I would switch to because I didn't want to pay double for services I didn't need. So Orange was able to proactively, even before I contacted them, look for in their package of offerings something that matched my level of need and matched their level of cost. They offered to me. It was very easy for me to just say yes. I didn't have to think about it anymore, and they took it. So this is an example of predictive classification. Again, you're it's not a matter of predicting how many customers you have or not, or how much they're going to pay or not, but just are they going to stay or not? Yes or no, that's a classification problem. This example is from project management. And in project management, the fundamental outcome that is the primary concern is whether a project succeeds or fails. So a project is generally defined as a set of activities that have at least three parameters. They have a start date and an end date. They have a budget, so there's a cost involved, which is often financial, but might also be resources, such as how many people would be allocated to them in that time period. And most important, they have certain outcomes, certain things they expect to achieve. And when a project achieves those objectives within the budget allocated and in the time frame scheduled, that project is considered a success. If it does not meet one of those criteria, that is, it doesn't do everything it set out to do in the time frame that's scheduled with within the budget allocated, then it's considered a failure. Now, that might be stark. Sometimes there's a middle category called a challenged project, where maybe it meets its objectives, but over budget, over time. But let's just stay in the simple success or failure framework. Now, a lot of organizations have a lot of projects, and whether these are governmental organizations, commercial organizations, education institutions, they have one project after another, and each year they might have, let's say, a portfolio of 10 projects that they carry out, or at least that they start, because some projects last longer. But suppose the company has 25 possible projects to choose from. Well, they would like to start the projects that have the greatest chance of success. They don't want to start a project that will eventually fail, because a failed project is a lot of wasted uh, time, a lot of wasted money, a lot of wasted emotion. So they would rather invest in and choose a project that have a higher chance of success and bypass the ones that look like they have a higher chance of failure. So being able to predict from the very beginning, and sometimes this is years in advance, the likelihood that a project will fail or succeed is very important because Here you have fail or succeed, two outcomes. This is a classification problem. And the possible criteria which might help to determine whether success or failure might occur are things such as how large the project is, how complex it is. The larger, more complex, the greater there are risks that things might not go along well. Sometimes the prior experience in the company. If the company has successfully carried out similar projects in the past, then a new similar project will probably have higher chance of success. But if the organization has never done such a project before, they might have higher risk of failure. So there's many criteria that an organization can use to try to understand and try to estimate the chances of success and whether they should carry out a project or not with the goals of predicting success or failure. And because of that dual outcome, this is a classification problem. This example related to airport management covers supply chain management, operations management, but it's something that we're all very familiar with since we've all flown on airplanes. And one of our concerns as passengers is, will our flight depart on time or will it be delayed? Because delayed flights are very frustrating, especially if we have a connection and so on. But let's look at this problem from the airport management perspective. So, the airport management has a huge concern in on time flights. For instance, it determines which gates to make available for new flights that are coming in. Because when flights are still in the air, getting ready to land, they need to tell them which gates to taxi to. And if there's a flight, if there's an airplane sitting already at a gate, but that airplane is delayed, then the gate will not be available for new flights coming in. So it's very important to be able to estimate whether flights will be on time or not. Now, ideally, it would be nice to find out if how late a flight would be, uh, whether it would be 10 minutes late, 30 minutes, an hour late. But that is quite challenging because predicting how many minutes later would be a regression problem because regression predicts specific numbers. And this is quite challenging. However, if the question is simplified, instead of predicting how long it will be late, but simply will it be late or not? And it could be simplified in saying, okay, let's give 10 minutes allowance. Let's be generous. If a flight is departs no longer than 10 minutes between when it's scheduled, we call it on time. But if it departs later than 10 minutes longer, whether 15 minutes longer or 2 hours longer, then we call it delayed. And by changing the problem to a classification problem, on time or delayed, prediction becomes much easier. That is, predictive algorithms can often more accurately get a prediction, even if they don't know how long it will be delayed, but whether it'll be delayed or not, they can usually do that better than the specific amount. And the criteria of determining how whether or not a flight might be delayed might depend on the weather. That's probably the primary condition. The weather not only in the local airport, but maybe in major connecting airports. There's a storm at some major hub airports, then there's going to be ripple effects that might affect our airport. Then there's things such as the day of the week. There might be certain days of the week where there's more traffic, and so there's more likelihood of delayed flights. It might depend on which airports the flights are coming from. Some airports are not well managed, so a lot of flights leaving them are delayed, and so that will have an effect on whether the flight that we're expecting to come from that airport will leave on time. The airline company also has an effect. Some airline companies just manage their schedules better than others. And so when we look at all these different factors, we might be able to predict with some degree of accuracy whether or not flights will be delayed. And again, because we're predicting whether they'll be delayed or not, rather than predicting how long they're going to be delayed, this is a classification problem.